Today we will be working through what is called dimensional analysis. Dimensional analysis is just a fancy word for converting between units. First, I would like you to turn to the first page of your green book and look for the conversions section on that page. The conversions that you will need to know for the regions are all found there. You won't need to memorize any of them. If you can't find this page, please pause this video until you can find it. Now that you are looking in the correct place in your green book, we're going to talk about what a conversion factor is. A conversion factor is just a ratio of two equivalent measures in different units. The most common example is one with 1 day being equivalent to 24 hours. And we say that this conversion factor is equal to 1 because they're both equivalent. So the same way that 4/4 would be equivalent to 1, 1 day and 24 hours are equivalent, so that is equal to 1. Also know that these are reversible. It doesn't matter which unit goes on top and which unit goes on the bottom. So for example, 24 hours and 1 day can be written in either order. We're going to complete each of the following conversion factors either from our common knowledge or from a reference sheet. The first one, we know that 12 inches is equal to 1 foot. If you didn't know that, that would be one I would commit to memory because it's one of the most commonly used one. And it is also one of those that I do not see on my reference sheet. So you should want to memorize that one. The second one, 1 pound is equal to 16 ounces. That one is on our reference sheet. 1 mile is equal to 5,280 feet. I apologize, my stylist is not cooperating. 2,000 pounds is equivalent to 1 ton. And remember that you can actually rewrite these as their reciprocals and they will mean the same thing. Now we're going to put these conversions to practice. Notice how the steps that I am giving you to complete are off to the side, and you should be looking at those in order to know how to set up these conversions. So Becky ran a sprint for 100 feet in 3.1 seconds. What was her speed in miles per hour? Notice how miles per hour is a ratio. Okay, that ratio is kind of what we're looking to find. So it says round your answer to the nearest hundredth of a mile per hour. I'm going to start with the ratio that I know. And I'm going to put 100 feet over 3.1 seconds. So I am writing the original rate as a ratio. Write the units in the goal rate as a fraction. So that means what we're looking to find. Which in this case, we're looking to find miles per hour. So I'm going to write over here that I want to get to miles per hour. That lets me know that I'm going to need to follow some sort of steps to end up with those units at the end. So I now need to look at my reference sheet and identify some conversion factors that will be needed to convert the rate. One thing to keep in mind is when units are on the top and bottom of a ratio, they cancel out. That's really important to remember. So we want feet to cancel out because we're not looking for feet in our final answer. So I'm going to look for something that's going to have miles on top because that's what I want at the end. And I want my feet to cancel out. So I'm looking for some sort of a representation of miles compared to feet. So if I look on my reference sheet, I'm going to see that 1 mile is equivalent to 5,280 feet. So when I do that, the good news is my feet are going to end up canceling out. My units cancel out when they're on the top and the bottom. The problem is right now the units that are left over are miles and seconds, but I need miles and hours. So I need to do one more conversion that will help me figure out how I can get hours on the bottom. And I need seconds to cancel out. Sorry if you can't read that, but there are actually 3,600 seconds in 1 hour. So now I have seconds as my units that are going to cancel out. And if you look, the only units left are miles, which I wanted to end up with on top, and hours, which I wanted to end up with on the bottom. Once you have the correct units in the correct spot, you are going to multiply the original rate by the conversion factors that you have. So in this case, I'm going to take 100 times 1 times 3,600 on the top, because those are my 3 numbers that I have on the top. And on the bottom, I have 3.1 times 5,280 times 1, and we'll see how many miles per hour I have left. When I multiply my numerators of my ratio, I get 360,000 over 16,368, which if I divide that so that I have a unit rate of 1 hour, I will end up with 21.9941349, but we need to round that to the nearest hundredths place, as it says in the question. So that is going to result in 21.994 miles per hour. So just to recap one more time, you are looking for conversion rates so that they end up putting the correct units in the correct spot with what you're looking for. See if you can give the next one a try on your own and then check back in with the solution. Pause the video now, please, while you work. So notice my setup. I've started with what was given to me in terms of my units, and I wrote down my end result of units and where I want them. Do I want them in the numerator or the denominator? That is important. So you need to make sure you have them in the right spot. So for this one, I know that I need my feet to cancel out. So I'm going to need feet on the bottom so that my top and my bottom are going to cancel out. I also need inches on the top, and I know that there are 12 inches in 1 foot. So that conversion rate is going to help me so that I get inches in the numerator and feet to cancel out on the bottom. Notice how this conversion rate deals with distance. And my next one is going to help me figure out time. So my next one that I need to use needs to have hours in the top and minutes in the bottom so that my hours will cancel out because I'll have one in the top and one in the bottom. And I will be left over with minutes in the numerator. I'm sorry, in the denominator. So I know that there are 60 minutes in 1 hour. So now it looks like I have feet canceling with feet. I have hours canceling with hours. My inches are on top and my minutes are on the bottom. So it looks like now I'm in a position to multiply. 52.68 times 12 times 1 all over 1 times 60 will give me a certain number of inches in a certain number of minutes. That's going to result in, when I multiply, 632.16 inches in 60 minutes. The question, though, asks per minute, not per 60 minutes. So I need to divide, and it tells me to round my answer to the nearest hundredth. So when I divide this, I'm going to get 10.54 inches. Oops, I can't spell. Inches per minute. The next page has a bunch of Regents application questions that involve dimensional analysis. Please give those a try, and when you're finished, check with Google Classroom for the answer key.